Yeah, we are looking at still questions on first order and second order differential equation. The last two questions we saw was basically on first order. But if you look at this one, given that y1 is equal to this, is a solution, is a solution to the differential equation, and this is that differential equation. But this differential equation is homogeneous and is second order differential equation. A, use the reductions of order to find a linearly independent solution. Okay, one of the solutions has been given to us. Okay, we want to find the second solution. And then B part says that use the variations of parameter to find the general solution to the what? To the non-homogeneous equation. So this second part, and this one is what? Is equal to, it's not equal to 0 here, it's equal to s squared. And this one become what? Non-homogeneous because it is not equal to what? It's not equal to 0. But if you check the two differential equation, they are the same thing. It's just that this is equal to 0, which make it to be homogeneous. And this one is not equal to 0, which make it what? Non-homogeneous. So let's go straight to the problem. If you are using reductions of order, you are using the reductions of order, you must know the standard form for that uh, uh, reductions of order. So for reductions of order, the general form is of this, second differential, p of x, first differential plus q of x times y equals to what? If it's homogeneous, it will be equal to 0. If it's not homogeneous, like this case now, it will what? It will be equal to f of x. Okay? So we're going to force this given differential equation to be of this form. And how do we force that? We're going to remove this attachment to the second differential. That means we're going to divide all through by x. And that will become this plus this x plus 1 over this fourth differential, then plus 1 over x y equal to 0. So this is homogeneous. Okay, then the next thing to do now, we are corresponding this with the standard form for reductions of orders. Okay, then it implies that if you correspond well, it implies that your p of x is equal to what? Is equal to negative of what? X plus 1 all over this. So that's the p of x. Okay, and what is the equation when you have the first solution and you're looking for the second solution? The equation is very simple. The equation says that the second equation will be equal to um, exponential minus f of x dx all over y1 is here, and then what you have here also was square. And then this dx, the element of integral, is here for this integral. And for the everything here, we have this one here. So that's the equation. We just need to begin to substitute. And when you are substituting, it is going to be what? My y1 is what? My y1 has been given as what? Ex times integral of, so integral of p of x, look at p of x, minus is there, minus is there. Okay, so that one cancel out. So we have exponential, we have x plus 1 over x dx. And this one will be equal to ex squared dx. Okay, so we're going to solve this one first. We're going to solve the p of x, the integral of x plus 1 over x dx. So this will be x over x, that's 1, okay, and then plus 1 over x dx. And this will be equal to x plus ln x. So that one is done. Then we now have y2 equal to exponential for x. And we have e x plus ln x, because we've already gotten this place, we've gotten that, which is x plus ln x all over e2 exponential to 2x. Okay, dx. Then we can combine the exponential together using indices, and that will be equal to this one, integral of this, and this will be equal to e. The base are the same, so that means you are subtracting because you are dividing, plus ln x. I'm using indices, minus 2x dx, and this will be equal to e x integral of e ln x x minus 2x plus minus x dx. Okay, so this is what we have now. Then what we have to do now is for us to just do algebra. This one means exponential ln x times exponential minus x, and this will be equal to this one we have here, and then integral. Don't forget that exponential ln x will give you this. Then you have e, you have this dx. Okay, they put this here. So that's what we have now. We just need to integrate, and that will take us to integration by parts because it's a product. Okay, it's a product. Okay, if this one is x squared now, we could have used a change of variable so that this one they will cancel out. But this is not so. The best way is to use integration by parts. You can take this integration out. So whereby my u is x and the u is equal to dx, and then because this one is better to make it your u because it becomes simpler on differentiation. Then the v is e minus x. Okay, they integrate both sides. You have v equal to what? Minus x. Integral of this is the same thing. It's just that you have to divide by the attachment to that variable of the power. Okay, and the attachment is minus 1. Okay, so then this will be uv. This will be uv, which is equal to minus x e dx minus v. My v is what? My v is minus dx du, and my du is what? Dx. That will be equal to minus this, the one you have here, minus that's plus integral of e minus x dx, and that's equal to the integral of this now dx is equal to minus this. Okay, minus that. Then integrate this, which will be equal to what? The function itself. Then divide by the attachment to that variable, and that what? That don't make it to be minus there. So we've gotten that. That's the integral of that. So finally, y2 is equal to what? Y2 is equal to exponential to power x, and then into brackets minus this. So we can open this. If you open this one and this one by indices, they become 1. Okay, this one plus this one, that's e to power 0. So that's 1. So I have minus x there. Okay, this one also and this one also will also give you e to power 0 using your indices, and that's also what? Minus 1. So that's y2. So y2 is what? Y2 is this. Okay, we have done that. We've done what we are told to do. So y1 for the given problem is this, and y2 is what? Is minus x minus 1. Okay, then if you want to go further, since it's homogeneous, we can get the general solution for this. General solution for the homogeneous will be equal to c1 y1, okay, plus c2 y2, and then that will be c1 is a constant, this, then plus c2 into bracket minus x minus 1. Okay, so that one is done. Then the next one is now to go to the b part. The b part is saying that use the variations of parameter to find the general solution to the non-homogeneous equation. Okay, so let's go there. Okay, we have this expression. Minus x. This is non-homogeneous part. Equal to x squared, and this also must also conform to the non-homogeneous form, which is the this plus p of x y plus q of x y equal to f of x. So it must conform to this. Okay, before we can so that we can, because for you to use the relations of parameter, it must conform to this standard form. Okay, so in that case now, what do we do now? We need to remove this one. We have done that in the first part, which is we now have now this minus this all over this, okay, plus 1 over x y equal to s squared over x. That's that. So I have my f of x now as what? As x. That's my f of x. Okay, so let's go straight to the variations of parameter. In variations of parameters, actually the question asks us to get the general solution. The general solution will be equal to what? Will be equal to the homogeneous part, then plus what? The particular solution. So we want to get the particular solution now. We want to get the particular solution. Variations of parameter is v1 y1 plus v2 y2, where your v1 is equal to integral minus f of x y2 the function of x, then a dot the Roskian of the linearly independent solution y1 y2 then dx. Okay, so that's what we have now. So what do we do now? You can see the a is just the attachment to your second differential, which is 1. There's nothing must be there, so that one is 1. Okay, so then v2 is equal to integral f of x y1 as a function of x all over a dot the Roskian of the linearly independent solution. So then what we need to do now, we need to get the Roskian. This w is a Roskian function. We need to get the Roskian of this solution, which is what? y1 is this, and y2 is minus x minus 1. Okay? Minus x minus 1. So that will be equal to the determinant. That will be this, and then minus x minus 1. So then the derivative of this is this. The derivative of this one is minus 1. Okay? So if it's two functions, we just have to do the first differential for the second line. If it's three functions, you do the first one here, you do the second one here. Okay? Then this will be equal to this one times this one. That will be minus this, then minus this one times this, minus x ex, and then minus this. Okay? No, that will be plus this, because it's this. It's this into bracket minus x minus 1. So, and don't forget minus. Minus. This is what I'm doing. This one times this one, then minus ex into bracket x minus 1. So this one times this one. Even the first one is plus. This one times this one, that's plus. And then what's plus also. So this one will cancel out, and then you have what? You have this. Let me explain that better. This time this is giving you this. Then minus this ex times this expression. So minus will give you plus. And then minus here give you also plus. So that's the Roskian of that solution. So we can get the v1 now as a function of x. v1 is what? Minus f of x, okay, minus f of x is x dot y2 is what? Minus x minus 1, okay, all over the Roskian is just this. So we can take this minus outside, and that will be minus, and this one will cancel out, and that will be what? Integral of minus x minus 1 e minus x dx. Okay. For this one, we can also factorize negative here. We can take negative out, and that will be x plus 1. So if that one minus outside to become positive, Then we have what? We have x plus 1 e to the power minus x dx. So that's what we have there. Then I think we can use integration by parts to do that. So use what? Use x plus 1, because this is a product. Can use integration by parts. The u is what? Dx. Okay? Then the v is dx minus x dx. So v is what? V is e minus x divided by minus. So uv is what? uv is e minus x minus that into bracket x plus 1, then minus v. My v is my v is this dot du dx. Okay, we can start expanding now. This one and this one, that's a minus x e minus x, and then minus e minus x. So we have that. We have that. Then here, minus minus, that's plus. Integrate this one, that will also give you minus what? Minus, yeah, this one has been expanded. We have minus x e dx, e minus x minus dx. The integral of this minus minus become plus. If you integrate this, that will be the same function, then the minus. Okay, so that's what we have here. That's what we have there. It was minus this minus this minus this. That's minus 2 e 2x. So that's my v1. Then v2 will be equal to integral of f of x, which is equal to my f of x is what? That's x times y1 all over the Ruskin is x dx. So this one and this one will cancel. I just have this one, so we also cancel. This is your f of x, okay? And then y1 is ex, okay, all over the Ruskin. So that will just have integral of dx, which is what? Which is x. Okay, so the particular solution for this non-homogeneous will now become v1 v1 y1 plus v2 y2. My v1 is what? My v1 is this, which is times ex minus x e minus x minus 2 x. Okay, then plus v2 is x into brackets, y2 is minus x minus 1. Okay, so this is a v2, which is yep, so that's what we have. We just need to do the little algebra there. Just need to do the little algebra there, and then the little algebra there is just to expand this one times this one. This is a plus here, this is negative, so that one cancel. You just have yp equal to what? Equal to minus x, okay, times 1. Then this one also, this one times this one, so that one also cancel. Just have minus 2, okay, we have minus 2, then plus plus. Let's do the expansion for that one. So that will be equal to, if you do the expansion, that will be minus s squared, and then minus x. That's minus x. So we have, in this case now, yp is equal to minus x squared minus 2x minus x. So that's the minus s squared, okay, minus 2x minus. So that's the particular solution. So the general solution will be equal to the homogeneous part plus the non-homogeneous parts. Okay, so and then we have the expression for that. I think I cleaned it up, which is what? C1, okay, C1 y1, which is this, plus C2 y2. My y2 is what? Minus x minus 1, then plus the particular solution minus x squared minus 2x minus x. So, 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 so that's that. That's that, which will be equal to C1, this one, plus C2 minus x minus 1, then plus. No, we can just this minus. That's if you want to, that will be equal to minus x squared minus 2x minus x. So that's the general solution. That's the general solution. That's the general solution.